Have you ever noticed your robot driving down a perfectly straight and empty hallway while it shakes and jitters like it has had way too much caffeine? This nervous behavior usually happens when the machine is trying to move forward but cannot seem to commit to a single direction for more than a fraction of a second. You might think your hardware is failing, but the truth is that your robot is actually caught in a high-speed argument between two different software brains. The first brain is the global planner, which looks at the big map of the whole building to draw a long and solid green line towards your final goal. This plan is great for seeing the big picture, but it is totally blind to the real world and any small obstacles that might be currently sitting on the floor. That is where the local planner comes in, by shooting out hundreds of tiny blue whiskers called trajectories to test every possible turn and speed for the next few seconds. The wiggle starts when the local planner sees a small shadow or a tiny bump on the floor and suddenly decides that a straight path is no longer safe. If your safety buffers are set too high, the robot feels squeezed between the wall and the obstacle, making it panic and searching for a way out. 1 millisecond the math says left side is the slightly better one, but the next millisecond it switches its mind and tries to dive back to the right. Because the robot recalculates city's choices 20 times every single second, those tiny shifts in direction shows up as a characteristic high frequency jitter. You can fix this by turning your parameters to give the global path more weight, so the robot stops overthinking every tiny pixel it sees in its sensor data. Once you smooth out those local preferences, your robot will finally stop second guessing itself and start driving with the confidence of a professional. It stops reacting to every tiny piece of sensor noise and instead focuses on the big picture, so stay perfectly aligned with the main road. Turning your planners is a secret to turning a jittery machine into a smooth and efficient navigator that reaches the finish line without breaking its